it has the RGB format that explains the 3 at the end. And then we also specify the output condition. So we are returning we're also returning an array of 1. And then we have the label list size. So it will use, returning the label list size. Remember the label list that contains all the different items that the model can recognize. So we take that, that list and then get the size and also return that too. So in this case, we are working with only one image at a time, and we need a way to tell that to the ML kit. And this image will be converted to a byte buffer and then sent in through the add method of the Firebase model input builder. Finally, we can run the interpreter after setting the input and the output and the output format options. The results are returned through the success or failure listener, and this returns an array of probabilities as our input based on the label list we entered. This result can then be mapped to the labels we specified so that we know what probability each label has for each input. So if you have a map of maybe cat and dog, you get a result of arrays, probably 0.4 and 0. So if you get 0.4, that means it looks like there was something that resembled a cat in this picture, but I'm not really sure. And then for the dog, if you get 0, it means that it doesn't feel there was a dog in that picture. So finally, we run the interpreter after setting all of that, and we get our result. So in this case, I used a crossword puzzle as my input data, and then I got back the results, and I got back a list of, so for the mobile net, there was a list of 1,000 items, and I got back a list of 1,000 probabilities. But what you do in this case is just to, after mapping them, you find a way to map them to the original list, and then, of course, crossword puzzle is 1.0. You only get 1.0 probability when you are like very, really sure that that's what's in the image. And it's also accurate because the other items in the list were returned, the probabilities were 0. So yeah, the summary of all I've been saying for 40 minutes is MLKit makes it really easy for Android developers who are either beginner MLKit developers or really advanced ML developers to build smart apps. If there's one thing you take away from this session, then this should be it. So I didn't come up with this alone. I used a couple of resources. You should check out the talk by your friend Guo at CloudNext 17 about TensorFlow. I watched that. There was also the Google Code Labs on TensorFlow, TensorFlow Lite, and the MLKit. There was the MLKit official documentation, which I had to read like 3 times to like get it to work. And then I used a couple of sketches in the slides, and I got that for free from that website. Thank you very much. Do we have time for questions or no? Do we have time for questions? Yes? Okay. Please pass the mics to them. Please raise up your hand if you do.
Hi, my name is Taiwo.
Hi.
I want to ask, where can we get models, like custom models online for MLKit? Because I feel that there are a lot of models that we can use to make our apps smarter.
Okay, so the thing is, I don't know if there's a site that has, like, okay, here's a list of all the custom models you have.
Like maybe a link online, like GitHub for models, something like that.
Okay, so I don't know if there's a link to free, you can do a search, but I don't know if there's a link to free models, but I know that there's, I can't remember the name right now. There's one that recognizes digits, numbers.
Okay.
I can't remember that, but I'm sure if you do a search on that, you'd
We'll get
find
some.
information. Yeah.
Okay. And is the learning curve for learning ML how to make, how to use TensorFlow Lite? Is the learning curve pretty
Well,
easy?
it's a bit wonky because I'm not sure I know how to fully use TensorFlow Lite yet, but at
Okay.
least I know how to import the TensorFlow Lite model into
Model.
ML Kit
Okay.
and then use Kotlin and my Android dev knowledge to build smart apps,
Smart apps.
which is really the point of the ML Kit because
Exactly.
it's telling you, like, say, you really don't need to go through all of that. But the way I look at it is that, well, Android developers might not be required to build the models. So the way you have an app and then someone gives you APIs,
APIs to
might be
work
the way
with.
you have your app and then someone gives you model and you
Models.
just need to ensure that it's in the TensorFlow Lite model.
Okay.
But it's also good if you can learn how to build it yourself.
Okay, awesome. Thank you.
Okay.
Hello, my name is Ibikunle Adeolua.
Hi.
Yes, in the demo code which you displayed to us, I noticed you use them hard-coded values for the dimensions of the
Well,
image.
that's because I know I'm working with mobile nets and I'm working with an image and I know the kind of image I'm passing in. So it depends. For some, you might require, the values vary depending on what kind of model you're using.
Okay, let's assume I'm trying to send a model to the machine learning. I'm trying to send a batch image to the model,
A branch image.
like a batch of images.
Okay. No, you
with-
can't. This process is only one at a time.
Oh.
I tried it. I actually tried it, and I got an error.
Okay. Yeah, thank you.
But
very
you
much.
you can build your own model that accepts a batch of images. So it doesn't have to be this and that. I think that's the advantage of the custom model. Like you can do whatever you want if you know how to build a model.
Hello.
Okay.
My name is Okwe. I just want to know how heavy is the library when you implement in Android app?
Okay, so I didn't measure it, so I can't really say. But the thing is that it's going to be really smaller than inputting your whole model into the app by yourself. It's going to be smaller than that. And then since it's specific, it's not like you're getting the whole of the Firebase APIs. It's specific Firebase dash model dash, I can't remember the entire name, but I don't think it should be too large. I didn't check it, so don't quote me anywhere. But I don't think it should be too large. All right, looks like that's all the questions we can take. Thank you very much.
Thank you all for coming. Unfortunately, I can't see you because I see only black something in front of me, but I'll try to nevertheless speak about Kotlin Coroutines. So, I'm Svetlana Isakova, I'm a developer advocate, and today I want to focus on Kotlin Coroutines, introduce them, explain why it's so important feature in the Kotlin language, and show you some examples of how to use them. So let's start. The main purpose of Kotlin Coroutines is to simplify asynchronous programming. And Kotlin Coroutines, in essence, give us a new way to perform all these asynchronous computations. And it is not a Kotlin invention. The coroutine is not a Kotlin invention. The term coroutines, the concept of coroutines, is known for many years already, for many decades. And at the very beginning, it was used to emulate asynchronous computation, even on when we don't have multiple threads. And now Kotlin just reuses this concept, and we now have it in the language. And now I will explain what it is and why we have this. So let's start with the motivational example. And my motivation would be I'll start with the example for async await. And at first, let's start with this very simple piece of code. And it is very simple, consecutive, and straightforward, but it is wrong. The problem with this code is that loading image might be a very time-consuming operation. And while this image is blocked, if we perform this code, if we run this code from the main thread, our user might be blocked because it takes a long time to load actually this image. And there are different solutions to this problem. One of the solutions is to use callbacks. There are, you can use them directly, you can use different frameworks. However, it's still callbacks, and in this case, you have to extract what should be done when your operation is completed inside some lambda, and specify that this lambda should be invoked afterwards, after your code completes. And using these callbacks often lead to some not really nice, to different problems, especially concerning that the code is not easy to read, especially when you have a lot of callbacks one inside another, and sometimes it is called callback hell when you have a lot of indentations for these callbacks. And the solution to this problem, alternative solution to this problem, would be to use async await. And async await, in essence, allow us to avoid using callbacks here, and it allows us to just write this code directly. And if you look at it, it looks directly like our first wrong example. So it is very similar to it. So we just write the code consecutively, one instruction after another, without some kind of callbacks, and it somehow works. Note that I haven't yet explained you how this async await works. My first idea that I want to share is that we want to avoid callbacks, and the feature of coroutines and async await allow us to do that. Async await is also not a Kotlin invention. It is the feature already present in some languages, for instance, C#. And if you look at it in C#, this feature is a language feature. So this async await are language keywords. In Kotlin, they are not language keywords, but they are just library functions. And in Kotlin, it works on top of the concept of coroutines. So somehow the concept of coroutines allow us to have async await in the library and to enjoy the power of async await. Coroutines allow much more than just async await, and we'll discuss it a little bit later. But for a start, I want to focus our attention on this async await. So now I want to talk about what is a coroutine. So coroutines somehow allow us to have this async await. And I want to compare two concepts, the concept of a thread and a concept of a coroutine, and see what are the similarities with them and what are the differences. So in essence, a coroutine is very similar to a thread. So it is something that on the first glance looks like a thread. In which sense? Thread is a sequence of instructions, and multiple threads might be executed concurrently and can share some resources. And for coroutines, the same also works. And a coroutine is also called a lightweight thread. That means that we can have much more coroutines, that we can create much more coroutines for our application than threads. So thread is a rather expensive thing. It requires a lot of memory, a lot of resources. And for coroutines, it's no longer the case. Coroutines are really lightweight, and we create like tens of thousands coroutines in comparison to threads in our application. So coroutine is something very lightweight. So now we know that coroutine is something similar to a thread, but we can have much more coroutines. Then let's discuss how they are different, how coroutine is different to a thread. And to explain this difference, I will use the following pictures. So in my talks, I will have lots of pictures today. I understand that it's second half of the day, so you might be tired. I hope that pictures will help. For my notation, I will use the following. So the thread will be the line always, and coroutine is like this computation, and it will be drawn as this block. So the next level, the next understanding of how to think of what a coroutine is a computation that can be suspended. So it can be run on top of threads, in different threads, and we can suspend coroutines. So somehow we may take this coroutine from the thread, put it somewhere in memory, and later return it back. The question is, why do we need to suspend a computation? Why do we need to suspend a coroutine? And the answer is, like even from this picture, you can see that when we suspend it, our thread is free. It can be busy with something else. So for another example, let's consider a situation when you start some two asynchronous computations from a main one, and you need to wait for the result. If you write this code straightforwardly via threads, like start from the main thread this computation, another one start them in parallel and wait for them, then while waiting for this computation to complete, your thread will do nothing, and your thread won't be able to do something else. And that's a problem. And if it's just a regular thread, it's just too expensive to lose threads in such a way. But if it's a main UI thread, it's even wrong because our thread is blocked and your user is also blocked. So that's why this situation with threads doesn't work really well, because like you cannot write such code. It is readable and straightforward, but it's wrong because you're blocking threads. And coroutines allow us a very interesting thing. You can write very similar code to the one that you would write using threads. However, here you can suspend a computation. And in this case, when you suspend this computation, your thread is not blocked. And this thread can be busy with something else. If it's main thread, then it's like a requirement to have it available for all the requests from the users. So coroutine is a computation that can be suspended. And in Kotlin, we have the special marker to mark such computation that can be suspended. And that is suspend modifier. When you see a suspend function, that means that this function represents this computation that can be suspended. So now when you write code in Kotlin using coroutines, you will see a lot of such suspend functions. Now let's go back to my image example and the story of async await, and let's unwrap how exactly this async await works. First, we want to start a new computation while loading the image. So we write the function load image async, and this load image async starts somewhere loading the image, so it starts a new computation on some thread. We'll later discuss on which thread exactly it should start. And then when we use await, when we call await on this asynchronous computation, that will mean that our this process image computation is suspended, will be suspended and later returned and later restored. So await, if you see how await is defined, you'll find out that it is defined as a suspend function. So here we call async, and async returns us an instance of a deferred type. It's a synonymous for future, something that is promised to complete in some time. And we can call await on such a deferred object, and this await is indeed defined as a suspend, which means that, yes, this is a marker that suspends our computation. So let's unwrap this example. We can extract this load image async into a separate variable to better understand what's going on. And here, at first, we started this loading image. We started new computation. And we have now two computations, one on the main thread that started another one, and a new one, like in my picture green one, that is loading the image. Then, when the code in the first computation reaches await, that is a marker that tells the compiler to suspend this computation if the result is not yet ready. So here, await refers to some computation of loading the image, and until the result is not ready, we suspend the main process image computation somewhere, and now our thread is free to perform another tasks. And then, when the result of a loading image, when the image is loaded and the result is already available, then we can return, then the compiler returns automatically our suspended computation to a thread and continues it. So that's how async and await work. You may ask here, on which thread my suspended computation will be continued? And the answer to this is that you specify that. By default, the default thread pool is used, and that means that your computation might be continued on any thread from the default thread pool. However, you may specify that, okay, this is something that should be run only on the main UI thread, and in this case, when you suspend this computation, you continue it on the main thread. And note how our main thread might be busy with something else when our coroutine is suspended. So when we have this blue coroutine somewhere suspended, we can perform another tasks on the main thread. So that's our win. That's what we wanted to gain. Sorry. So here, in this example, we probably set image on the main UI thread. So when we call async, we specify that this computation should be run on the main UI thread. However, there is another interesting story that Kotlin Coroutines are not only async await. So here we see this pattern, and it is the feature that you might be already familiar with if you found it before in other languages like C#, and that's exactly the same functionality. This async await allow you to run something asynchronously on a different thread and then wait for its result. However, Kotlin Coroutines are not only async await. you can do more things with Kotlin Coroutines. And one of the most important things that you can do is you can define your own suspend functions. So now the way how you write your code differs from your habits can differ, because now you can think in terms of defining something as a suspend function. So whenever you have something that might wait and block a thread, instead you can now declare it as suspend function. An example. Here we have simple consecutive logic. First, we want to log in our user to get some user ID, then we load some data using this user ID, and in the end we show the data. If we just write this code in this manner, in a consecutive, clear way, it will be wrong, because here we have two places where our user can be blocked, because we have here probably some network operations, and they may take a long of time, and during this time your user will need to wait. So that's something that we somehow would like to avoid, to block the user. So what are solutions to this problem? You can use completable features, for instance, to rewrite the same code and to allow to avoid this blocking user. Then you will need to use some API of these completable features, or if we are talking about probably Android or some other cases, you can also use RxJava. It also allows you to rewrite this simple, straightforward code in a RxJava style. However, for this simple case, when we just have some consecutive actions like login, load data, and show this data, in this case, in this scenario, RxJava might be a kind of overcomplication. So if you compare the initial code with what we have with all these frameworks, you'll find out that with frameworks, it becomes less clear in some cases that are not probably intended to be processed in this way. So what we can do with async await? Now we have the power of async await, and we can rewrite our code, our initial example, using this async await functionality. And how we do it is now when we implement our login function, instead of just performing our login operation, we try to perform it like somewhere in the background, and return a deferred object that might be awaited. So that's how we program with async await. We say, okay, start this login operation, then await for it. And the same with load user data. So now we changed the return types of these functions, two functions, login and load user data, now return as deferred objects. And after each call, we simply await for the result. So our code, to my mind, it looks more clear than the previous one with the RxJava frameworks, but probably it's a matter of choice. So async await help us here to simplify this code. Okay, so well, so good. But with Kotlin suspend functions, we can do even more. In this scenario, we can simply define these functions as suspend function. And that will mean exactly that this suspend function, that is some computation that might be suspended. So whenever we access for user login, that is a network operation that might be long, and we want to be able to suspend it until it waits for the result. So we simply define our function as suspend function, and you see that the code afterwards, the code that shows user info, is the same as we had in the first wrong slide when we blocked the user. So that's what we have, that's the benefit that we have with coroutines. We had our first very simple code that probably you write at the first when you just need something to get working and when you are not very concerned with the performance. But then when you start to understand that, hey, user need to block, need to wait too much and is too slow, you may decide to convert it to the suspend function. You don't need to rewrite everything and to change the model. That is not, that is kind of slight modification. And you can, whenever you write it, you can define them suspend. At the beginning, when you understand it, yes, this is something that might be suspended, but the main idea is that it is very similar to it doesn't change the way how you write code. You just add these suspend modifiers, but everything else stays the same. So we just added these suspend modifiers, and IntelliJ also nicely highlights, and they nicely highlight the suspension points of this coroutine, of this function. So in this case, so show user info function is a computation that might be suspended, and it might be suspended in possibly in two places. And we clearly see where it can be suspended. At first, it can be suspended when we call login, because it is also suspend function, so that's something that can be suspended. And it can be suspended when we load user data, again, because it's some point which represents computation that can be suspended. So we clearly see these suspension points. On the declaration side, because we have the suspend modifier, and when we use them, because IntelliJ nicely highlights them. You may ask here, where can I call these suspend functions? And the answer would be that you can call suspend functions inside another suspend functions, like in the previous example. And inside, we saw already async. Async is one example of such coroutine builder. There are some others like launch. So these are called coroutine builders. And the difference, the main difference between async and launch is that async returns you like a deferred object that returns you some result. So for instance, here it is a result, we have deferred with the that should return you an integer in the end, and launch returns you a deferred, some kind of deferred or future object without the result. So that's the main difference between them. So kind of launch returns you the deferred of unit, but there are different types. And if we look at how these suspend these coroutine builders are defined, we'll find out that they mark their lambda parameters as suspend modifier, with also with suspend modifier. And then the right answer to the question where you can use your suspend functions is inside suspend functions or is inside these suspend lambdas. But there's some kind of technical implementation details. You can nest coroutines inside, like you can start a coroutine inside another coroutine. So for instance, here we have the launch main coroutine, and we start async, we asynchronously load image inside this coroutine. And this moment, an interesting story begins, because there is like you may ask here, what about errors and what about exceptions? And what happens, for instance, if your nested coroutine, an error occurs in your nested coroutine, and will it be cancelled? Will the outer be cancelled, and so on? And the answer to this question, the solution to this, was finally introduced in a very recent update to Kotlin Coroutines. And like before, their general advice was that you have to handle it manually. However, now there is this concept of structural concurrency, and this thing also changes a little bit how you write your code using these concepts of Kotlin, of coroutines. So let's again look at some example. And here we have a classical example to show you two asynchronous computation. So we want to load two images, both asynchronously. So if you have enough threads, they will be loaded in parallel. And afterwards, when both of the images are loaded, we want to overlay them, to do something with both of these images. So we know now that we define this function. When we call first await, the main computation is suspended. Like for simplicity, I just I just say here that our computation is suspended once, but actually we have two await calls here, so our computation might be returned back, see that whether the second result is ready or not, and then suspend it again. So in this simple case, like that's fine, but what can possibly go wrong? And the problem here is, like, what happens if some exception is thrown inside coroutine? So while we are loading, for instance, the first image, the green one, what happens with the second image, for instance? And to answer that, first I need to tell you that, like, what generally happens with exceptions. Await just rethrows exceptions. So if your coroutine that you started throws some exception, you may catch it while calling await, and your exception will be correctly caught. If you don't so you can simply use a regular try-catch and surround this await function with try-catch to process this exception in the correct way. If you don't catch this exception, then it will be simply rethrown further upper. Like await just rethrows this exception. The problem is that if, for instance, an exception is thrown when your first image is loaded, then no one says the second image to stop loading. So no one canceled the second started process if you don't do it somehow manually. By default, nothing happens. So this exception is thrown upwards, and probably you want, in this case, to stop everything, to cancel all the started tasks. But by default, and like before this introduction of structural concurrency, this was indeed a problem. But now, with structural concurrency, we can say that, and actually not only we can say, but by default, all our coroutines that we started as structures are structured, and you start a coroutine in some outer scope. And in this case, like you see, there is the difference from the previous example is that we introduced, we are using now this coroutine scope. And the difference is that now, if one of your children coroutines is cancelled, then the outer scope, before returning, will clear up everything, will wait until its children are finished, or will cancelled if it's cancelled. So now these children coroutines are cancelled automatically if someone cancels their upper coroutine. And even in this case, when an exception is thrown in one of the child coroutines, it also means that the parent coroutine is cancelled unless it processes this exception correctly. So now with structured concurrency and with introducing of coroutine scope, you can specifically specifically start your new coroutines in some context, and they are and they are automatically processed. Their life cycle is depending on their outer scope. The difference that was introduced in this late release, so probably if you already used coroutines, you know that you can use async await directly from any point. And that means that these new coroutines are started in some global scope. However, now after this, after the latest difference in and in coroutines 1.0, there'll be these async and launch functions are defined as extensions on this scope. And whenever you launch or whenever you start a new coroutine, it's always started in this scope. So by default, you may specify, if you don't have some scope, you may specify that, okay, start my new coroutine in the global scope. So that might be a default option, but a little bit later I'll show you the better solution. So the difference is that now your coroutines are always binded, are always connected with the scope. And now, whenever you want to start a new coroutine in somewhere, in some other thread, some new asynchronous computation, you have to explicitly say that you have to explicitly define this function that starts a new coroutine as an extension on coroutine scope. So that's another difference that that brings this structured concurrency approach that influence how you write your code. So now, when we write this function load image async, and it starts a new coroutine, this loading image will be connected, will be binded to this outer scope, depending on what scope we're starting it from. In this case, we just used coroutine scope function, but the supposed way how to, like, where to bind all your newly started coroutines, all your newly created computations, is there is this question where to bind them, and the answer is that often you have in your application some objects with a well-defined life cycle. So if we are talking about Android, such object is an activity. So an activity is an object with a well-defined life cycle. When we're talking about some other frameworks, there are always, there usually some this kind of something with life cycle. And we can bind all our children coroutines to this life cycle. To accomplish it, you do a very easy thing. So, for instance, you can extend your, not extend, but implement by your activity coroutine scope. And if you implement coroutine scope, then you can start all your new computations. Do remember that now we can only call async and launch from some coroutine scope, because they are extensions to coroutine's scope. And now, because our activity extends coroutine scope, we can simply call async await, async or launch, or call our custom function starting new coroutines from this activity without any specification. So after you correctly define this scope for your class, then you can easily call this async await from the class, easily create new coroutines from your class, and they will be automatically binded to the life cycle of your class, of your object. So that's the core difference. Now, with structured concurrency, the life cycle of your coroutines is correctly covered, and it is bound to activity, to activity or another object in your system with its own life cycle. So I've shown you just implement the coroutine scope, and now how to implement this coroutine scope. That's also easy. That's just some pattern that you may use for your application. So whenever whether it's activity or some other class, their task is very easy. So you implement coroutine scope, and then you want to do some like little ceremony when you create your instance of your class with lifecycle and when you destroy it. So in the case of activity, we have on create and on destroy. And on create, we create so-called job. So job represents the lifetime of the activity. And in this case, we created we create this job, and whenever inside your activity you call either async launch or your custom async functions, they are bound to this job. They will be automatically bound to this coroutine context because you here overload this coroutine context library. And when your activity is destroyed, by calling this job cancel, you simply cancel all the children coroutines. So that's the main idea, how to control your children coroutines from your application. There might be a question. What is the difference between, not what is it, but when to use, when to define something as a suspend function, or when to define something as an extension to this coroutine scope? Because I've shown you that now you can it brings you the new way to structure your code and to write your code, because now in your application you define some functions as suspend function, meaning that they might be suspended because they require some job for something. If you usually your such functions may use some API that might be blocked, that requires callbacks. But there is a way how to use such API, rewriting it to such suspend functions. So you basically add some additional methods to the function, to the library, some library functions that are written with callbacks, and afterwards you use them from this coroutine model. So, but then let's go back to our question. Here we have a suspend function. We can now write some functions as suspend functions, and we also can start some new coroutines. And we know that when we start some new coroutines, we define it as a coroutine scope function. And they're proposed a way to distinguish between them and to decide whenever to use which is that when you define your suspend function and you are interested in its result. You are interested in its result immediately. Then you define it as a suspend function. So here you probably remember in my first example with this login, when I defined it as something that returns deferred, I have to call await right away. And this is a kind of marker that, yes, in this situation, suspend works better. But when you start some new computations, when you start new asynchronous computation, one asynchronous computation, or probably it will be several asynchronous computation, and then you either not interested in the result whatsoever, so they will just continue to compute on their own, that's fine, or you are interested in its result sometime later. In these cases, you are defining such function and as an extension on a coroutine scope. And the rule is like the convention, so it's like kind of a convention. The convention is not to mix the two, so not to define extensions on coroutine's scope as suspend functions in order to clearly understand the purposes of the functions concerning this suspension coroutines model. So that's new suggested ways of writing your code that might be suspended and that may require this suspension mechanism. Some implementation details of how these coroutines are implemented under the hood. So whenever you write some suspend function, under the hood, this suspend function in the bytecode level takes additional parameter. So it is generated to take this additional parameter, and the compiler automatically generates this parameter. So if we look at continuation, it's a kind of a generic callback interface. And to some extent, coroutines work through the same callbacks mechanism like before. Like when we start discussing that you can solve such problems with callbacks. However, now all these callbacks are hidden by the compiler, are hidden in the bytecode implementation of this function, and the compiler generates all these callbacks automatically for you. So that's one way to, like one simplified way to think about it. And when we are looking at like what is this continuation? So I show you that here we have some hidden parameter continuation, and what is this continuation? When we suspend a function, so for instance in this example, I have a function, and the first line login is my first suspension point. So when I suspend a function here, when I say that computation is stored somewhere, like this continuation interface, continuation object is stored, and it contains all the information of the exact point when we stopped this computation, when we suspended this computation. So this continuation contains information of the values of the local variables, of the parameters, the point where in the function are we, so that's automatically stored. So in a way, the rest of my function after the suspension point goes inside this generic callback continuation. And when we restore this function, it continues from, it restores its state and continues from the point where it was suspended with the newly results that we got from this suspension function. So the same works for the second suspend point. Here we have another, like the rest of the code becomes continuation, and for the same for the last suspension point, again, the rest of the code becomes this continuation. Another implementation detail is that the body of the coroutine is compiled under the hood to a state machine, and basically the number of suspension points that you find inside a function. So that's here we don't know how many suspension points do we have, because we don't know the implementation of login function, of load user data, etc. But when we store this this computation, this coroutine, it is implemented via the state machine, and each suspension point is one of the state. So when we reach first suspension point, we suspended the coroutine and then restored it, etc., etc. They continued to perform the code, reach the second suspension point, suspended it, restored it later, etc. So that was almost all about what I wanted to share about coroutines. Some like Kotlin Coroutines are much even more than just async await, then suspend functions and the exact coroutines. So again, the concept of coroutines lives in the language. So this language supports the suspend modifier for suspend functions, coroutine builders like suspend lambdas, and some ways to, and all this magic of suspending the computation and restoring it back. And everything else is built on top of it and lives in the library. So there is async await. There are also the support for more complicated concepts like channels or actors. You can also implement that via coroutine and use them. And there is a separate thing as yield. Yield is also in Kotlin implemented via coroutines. You can find information about coroutines in our site. So now you can read everything about them there. And also, I would recommend, if you want to learn more, there are talks at KotlinConf by Roman Elzarev, who is the lead developer of the Kotlin libraries, including Kotlin Coroutines. And here he explains this concept. And in the last talk at KotlinConf, he explains this concept of structural concurrency in detail. So if you want more about it, you can try it. So I'm all. Thank you very much for your attention, and have a nice Kotlin with coroutines.
That was a great introduction to coroutines. I'd like to take a moment to repeat some of the key points. Coroutines can simplify async programming by replacing callbacks. Let's write some code to make an imaginary network request. To make it interesting, we're going to start this network request on the main thread. The main thread is the thread that draws updates to the screen and handles user input. If we write our code in what's called a blocking style, where we return the result directly from network request, it will block the main thread. This is a problem because a network request takes seconds or minutes to complete, and the entire time that it's running, the main thread won't get updates. The user will see your app as frozen. When the app tries to refresh the screen with onDraw, it will have to wait until after the network request completes. This is called jank. If instead we write the same network request with callbacks, now the code won't block. Our networking library will take care of running the network request on another thread, and when the data is ready, it will call back to the main thread. The callback is the handle the library uses to pass data from the background thread to the main thread. After we get the callback, we can show the data to the user. Now, let's write the exact same network request with coroutines. It looks just like it did when it was a blocking function. However, since it's a suspend function, instead of blocking the main thread, when network request is called, it will suspend the coroutine. This frees up the main thread to go do other things like handle onDraw. And when the result is ready, it gets passed back to resume the coroutine. It's important to note that with coroutines, our networking library still uses another thread to run the networking request, just like it did with callbacks. The main difference is the code tends to be simpler than the callback version. Understanding suspend and resume is the key to understanding coroutines. Let's zoom in on what happens when you suspend. To make the example a little more interesting, I'm going to assign a variable x to the value 1. When we call a suspend function on the main thread, it gets added to the call stack just like a normal function. Since it's a coroutine, it runs inside of a coroutine dispatcher, which knows how to suspend and resume. Then the code continues like normal. First, it assigns x to 1, and then it calls another suspend function. And here's where things get interesting. Instead of adding network requests to the stack like a normal function call, onDataLoaded will be suspended. This means the current state of the function will be copied from the stack onto the heap. Then network requests will be added to the stack before it suspends itself to wait for the network result. Fast forward a couple seconds. The result is ready. The coroutine dispatcher will resume the coroutines where they left off. First, it'll resume network request. Once network request processes and returns the data, the dispatcher will resume onDataLoaded. Note that when onDataLoaded resumes, it's still in the exact same place. It doesn't start from the top of the function like a normal function call. Instead, it resumes where it left off. The local variable x is still set to 1. Our coroutine can now continue, assigning the result to a local variable and showing it to the user. By using this suspend mechanism, coroutines allow you to describe async operations using structured programming. This can greatly simplify your code. Let's take a look at a few examples of what structured programming with suspend functions looks like in Kotlin. To run two coroutines sequentially, you simply call them as if they were regular functions. Here, network requests will complete, then other requests will complete. And once both are done, show will be called. When a suspend function has a dependency on the result of another suspend function, you can just use variable assignment to store the result. Here, we're storing the result of a network request and using it to pass a value to another request. To signal an error, coroutines throw exceptions, which you can manage with regular try-catch blocks. And to call suspend functions repeatedly, you can wrap it in a loop. Or, if you prefer a functional style, you can use them that way in Kotlin too. Spawning multiple coroutines in parallel uses another function called async. When you call async, the coroutines run in parallel, kind of like a lightweight thread. To wait for the result of an async call, you can use the suspend function await. And if your coroutine needs to use a conditional, you can do that with an if statement. Here, we're getting the result of the first network request, and based on that, sometimes calling another request. Now, altogether, coroutines are a great way to simplify async code by turning callbacks into sequential code that uses concepts from structured programming. To learn more about coroutines on Android, check out the Code Lab using Kotlin Coroutines in your Android app. Stay tuned to DevFest on Air to see more of the top talks from GDG season 2018.
So this session, بعنوان Think Business, Sketch Like a Designer, and Code Like a Geek. 3 sentences usually مستحيل نسمعهم in one subject, صح؟ مين هون a student? Majority. Who's already working? طيب مين programmers? Designers? Our lovely designers? Business people? يعني product, marketing, anything. Designer, قد ايه بتحبونا نحن developers? You like us so much, right? Developers, how much do you like our friends, the designers? And our business people. They hate both of us. So let's see. Who am I and why? What am I doing here? My name is Rayan Al-Zahab. I'm a Google developer expert. You just heard about that program. 2 years back, I got invited to a conference in Casablanca. And they say, we saw your profile. We are interested into inviting you to attend a Women Tech Maker Summit to actually be with Googlers. As you know, I'm from Tripoli. 3 hours driving to the embassy of Morocco to get my visa. I apply my papers, and the guy is like, are you joking with me? You got invited by Google. Who are you to be invited by Google? كب الورقة بوجهي, literally, and he said, you're mocking me. You printed this page of the internet, and you're lying. Go. I'm not approving your visa. I'm not even taking your papers. Why do I tell this story? Is because this is the mentality we face in this region. العالم مش حتصدق إنه نحنا we have connections with Google أو أنا invited by Google لأحكي بconference أو حتى لما يكون عندي فكرة لما يكون عندي مشروع وبدي ابتدي فيه ما حدا حيصدق إنه عن جد حينجح. الكلمات اللي على الأغلب حنسمعها هي فكر حالك مارك زوكربيرج. الكلمات اللي أنا كنت أسمعها شفتي بحياتك بنت ونجحت بهيدا الدومين؟ شوفي كل اللي موجودين هلا في بنت ليه عم تعذبي حالك؟ ولقسم كبير من البنات بحب شارك هاي القصة كانت I always heard this وهيدا على راسك مش حتوصلي مطرح. With this scarf on your head you're not reaching places. You cannot stay with all your beliefs and make it in this world. You're gonna have to let go. Loosen up with your ambitions. You're too ambitious for a girl. Those are the sentences we used to hear. Well, today, from where I am now, a digital consultant at McKinsey & Co., a company that's been there in consultancy for 90 years. On Glassdoor, McKinsey is the most difficult company to get into. A Google developer expert for the biggest technology company in the world, Google. I say to all of those people, hi from where I am now. And I say to all of you, for me, it was my scarf. For you, it could be something else. It could be another challenge. It could be what you wear, your attitude, or whatever it is that women biases are today. Do not let go of anything you consider a principle just because you want to reach places. You don't have to. You can be whoever you want to be, whoever you believe in, and make it anywhere in the world. And for the places that you will not be able to make it, believe me, you don't want to be there. I don't want to work with the people who were racist enough to decline my job just because I'm a woman. I don't want to be in the company where they called me and they said, my name is Rayan, right? Rayan, for most of you, is a guy name. So they used to call him like, can I talk with Rayan? And I'm like, this is Rayan. No, I want Rayan, the programmer. I'm a girl, but I'm a programmer. And they were like, no, never mind, we wanted a guy. And they hang up on me. Well, you don't want to work with those people. You don't want to work with people with biases. You want to work with a place where you can be who you are and celebrate that. Last year, we had 8 Google developer experts in the Middle East and North Africa. 8 were men. Every event I was in was full of men. And then I got nominated by someone from Google, and they say, we saw you talking, and we think you fit in this program. I applied, and I used to not share this because it's very emotional for me. I applied, and the first time I did the interview, I got rejected. I passed my community interview. When I reached the technical interview, my interviewer said, you don't fit. But Google has a very strict rules. So they say, go ahead, those are the comments, work for 6 months on those comments, and come back again, and we will apply for you again. My first reaction was, I'm never applying again. No one likes failure. No one likes to be rejected. And when I applied, when I was nominated, I was so excited. I got nominated. I never thought I'm going to be rejected until I actually was. And my first reaction was I called the regional lead and I said, I'm sorry, I'm not fit for this program. This is what the interviewer said to me. I'm never applying again. And he said, it's okay. Now you're upset. Let's talk tomorrow. He called again and he said, you are fit for this program. You lack few knowledge in this area and that area. Let's work on that. This is what you need to work on. This is what you need to build. Let's have the interview in 2 months. In 2 months, I was so scared, I kept delaying the interview. Every time they tried to set up an interview, I say no. I'm busy on that day. I'm busy on that day. And I kept like rescheduling until I actually did it. I did the interview and I had no idea if I passed or not. But what I know, he didn't say you don't fit. 1 week later, I received the email to say, congratulations, you became the GDE. And then we have a female Google developer expert in the Middle East and North Africa. And I was so proud of that I actually left my job. I left my job and I said, I'm going to dedicate 3 to 4 months going around the Middle East and North Africa, talking at conferences, because those conferences never had a woman talking in them. So I'm going to go and talk to every conference I can, just to show the women out there that, yeah, it is possible. I'm very, very proud today to say, years when Google was doing events, they had those 8 Google developer experts who were male. Every time they go into a conference, no one ever nominated a woman. Not a single woman came to the regional leads and said, I think I fit for this program. Can you nominate me? It never happened. After we started roaming the MENA region and having one of the speakers a female, every single event today, minimum 3, 5 women sends emails saying, I think I fit to this program. Why? Because they didn't have an example before. And this is the difference. We see only men and we say, it probably is not a place for us. But when they saw someone like them, they don't see any obstacles anymore. And they want to be that thing. And I want you to be that example for every person around you. In addition, Women Tech Maker can help you all a lot. Ladies and gents. I'll start with the ladies. What is the program? What does it give you? It gives you 3 pills of help. 1, resources. You're gonna get access, if you go to womentechmakers.com, apply for the membership, which is just 1 form you fill, you're gonna start receiving resources. The latest in Android, latest in web training. 2, you're gonna get a lot of opportunities. Invitation to conferences, just because you are part of Women Tech Makers. With sponsor, with support. 3, network. You're gonna be part of a Slack group with all experts from around the world, from Google, from Facebook, from all of those companies who are part of Women Tech Makers. And you can chat with them, you can talk to them, ask them whatever you want. Here, I usually got asked from the audience, what about the men? Well, you guys, if you are a supporter of Women in Tech, you can also apply to this program just by filling this form, and you will have access to those resources. So I invite every one of you to go to womentechmakers.com and apply to the membership. So back to our topic. Think business, sketch like a designer, and code like a geek. I'm a software engineer for over 10 years. Lately, I took a job at McKinsey as a digital consultant. No, I didn't become a business person. I'm still one of you. I'm still a geek. I'm still a programmer. But I work as a digital consultant. Why I decide to give this talk, which is Think Business, Sketch Like a Designer, and Code Like a Geek? Because of this picture. Who have seen this before? Probably not everyone have seen this picture before, but I promise you, every single one of you have lived this picture before. My dear students, you go and you grab a project for your senior, for your web development course, and you start thinking about the project, implementing the project. And then you go and you show your doctor your first draft. She will say, can you do feature 1, 2, 3? You will go home, work on feature 1, 2, 3, go back after 1 week. This doctor, she probably saw over 20 projects during that week, 50 projects. Do you think she will remember exactly what you talked about? So you will come back and she will say, why did you do 1, 2, 3? I like better 2, 3, 4. And you're like, okay. And you go back in a dark room with your coffee and you're coding and you do 2, 3, 4. Next week you come back and the doctor will say, why 2, 3, 4? I want 1, 2, 3. What the hell? I just did that and you asked me to change it and I changed it and now you're asking me to change again. And she will say, no, I don't remember. Or, I didn't know it will look like that. Change it back. You are still a student in university. What's the cost? You lost 1 week of work. Imagine we are a huge company working on a product. We went on a release. We found out, oh no, this is not what we want. We lost thousands of dollars. Imagine I'm a programmer in a company and I work and work for a month. I go back to the business person and the business person is like, nope, that's not what I had in mind. Go do it again. So the customer will come and will explain what they think they want this way. Because we always think we know what we want until we are actually questioned. The project lead will understand it this way. We live in a global world, right? You probably are not talking with a person who is from the same culture, doesn't speak the same language. We both are speaking a foreign language. And even if we are from the same city talking the same accent, we're probably going to face a lot of misunderstanding. The analyst will design it this way, and the programmer wrote it this way. Beta testing, and the business, again, will file the first bill. That's that big. Documentation, who has time for that? أنا درست programmer to write code, not to write literature. I'm not going to do it. I only write code. I don't write documentation. True? Wrong. Documentation is what will save you. Operations. Who is here in IT, sysadmin, dev operations? Our lovely friends who forget half of our libraries. We go live and everything crashes. And then another bill arrives to the customer that was bigger than the first one. Support? Well, I deliver my app, I close my phone number, I change my home address, I disappear from the planet. That's the way it is, right? I don't want to hear support. I don't want to hear nagging of the customer. Marketing, blurry advertisement, but eventually, what the client actually wanted was a simple swing. From picture 1 to the last picture, we lost a lot of resources, energy, money, and time. Time is the most important. Why? Because today the competitors are just around the corner. If we skip the launch by a few days, we might not be the first in the market. We might lose our advantage value, right? So how do we actually avoid all of this? I worked in so many different jobs. I was a student, I worked as a freelancer, small companies, startups, big companies, and I noticed that this pain is the same across all of those. The pain is actually real. And when we go live, who do you think get the blame? The business people? The designer? Whose fault was it? Who's the one to blame in this cycle? The client. That's new. No one ever said the client. Usually, it's the programmer. This is what they say. The programmer. Because the designers will say, I draw it nicely. I did my job. The business people usually are smooth talkers. And they know how to get themselves out of it. And they were like, we know how, we talked with the client. We did our job right. It's the programmers who did it wrong. It keeps on crashing. Is it really the fault of the programmer? Definitely not. So let's see how we can, as a programmer, break this cycle and find a solution. We break this cycle by thinking business, sketching like a designer, and coding like a geek. And you will say, A programmer cannot think business. A programmer cannot be a designer. And the designers will hate me when I say a programmer will design. Well, let me tell you, every single one of you, even you, the photographers, you are designers. You design what you have. You design a database, they design a video, they design screens. Whoever built this building designed a building. Every single one of us is a designer, not a graphic designer, but as a designer. So let's see how we're gonna break this loop and not be the one who gets blamed all the time. First thing first, think business. Let's take off the hat of the programmer and put the hat of the business person. We are now business people. The first step is we're gonna define the goal. What is the goal? What are we trying to do? So let's take an example, Uber or Kareem. For the sake of this